Hello, today we're going to be doing 6.3, add and subtract rational expressions. So I'm going to do a quick review of the multiplication part, and then I'm going to jump into the lesson. So this first example, remember whenever we're multiplying, we're just multiplying top times top, bottom times bottom, and we want to look for factors that we have in common. So let's go ahead and factor this first one. We see that we can take a 5 out of 5x squared minus 45. And then if we look at the x squared minus 9, we recognize we can take that one step further. So I'm just going to write that down here. It would be 5x plus 3, x minus 3. And then the bottom stays as x plus 3 times 1 over. We also can factor a 4 out of 4x minus 12. And now before we even combine these, we can go ahead and start crossing things out that we see in common. So we have an x plus 3 and an x minus 3. So this one reduces to 5 times 1, which is 5 over 4. And there's our answer on this one. Okay. Again, for the sake of the video, I'm just going to go through these because it'll take a little while. So the adding and subtracting with like denominators, the idea here is you need to have a common denominator in order to combine fractions, whether you're adding or subtracting. So it's a little bit different than when we were multiplying and dividing. So let's start with this one here that says 2/8 plus 5/8. If you remember, you keep the denominator the same, and then you only add the numerators, or the top numbers. So in this case, it would be 2 plus 5, which gives us 7. And that's our answer right there. We can even do this when we have variables. So we have c and c as our denominators. So then what we're going to do is add the top parts. We don't know what a and b are, so we're going to leave it as a plus b over c. And we can't simplify that any further, so we're going to leave it like that. Here again we see 3 over 2x minus 7 over 2x. As long as you have the same denominator, you're good to go to start this one. So you just take 3 minus 7, which would be negative 4 over 2x. Now be careful, in some instances like this, we can reduce further. We know that 4 divided by 2 is 2. So our 2 on the bottom would go away, and our 4 on the top would become a 2. So then the answer is negative 2 over x. Here we're adding, we do have a common denominator of x minus 4. It has to match exactly. And then we can add 3x plus 6, but since those aren't like terms, you're just going to leave it in that form. Also, be kind of careful here. There's a chance that it could simplify down. So if we factor out a 3 from 3x plus 6, we'd have x plus 2 over x minus 4. So that doesn't change anything. We would have been good to leave either version of this, but just be cautious because sometimes they will simplify further. Now the hard part is when you add fractions that don't have a common denominator. So I'm going to do the number part first, then I'll come back to the variable example. So if we wanted to add 1/3 and 2/7, we need to think of the lowest common denominator between 3 and 7. And for this one, that would be 21. And the way that we change our fractions is we're going to multiply each of them. This one I'm going to multiply by 7 over 7. And this one I'm going to multiply by 3 over 3. This changes it to 7 over 21 plus 6 over 21. And then we can add those together now that we have a common denominator, and we get 13 over 21. Okay, gets a little bit more complicated when we have variables to work with. But notice, when we were multiplying by 7 over 7 and 3 over 3, we're just multiplying by 1. So it's still the same fraction value, it just looks different. Because 1/3 and 7/21 are the same. So a over c plus b over d, we're going to do kind of the same trick. We want to look at what one fraction has or it's missing. So in this case, we have a c, but we're missing a denominator of d. So I'm going to multiply this fraction by d over d. And then this one is missing c, so I'm going to multiply by c over c. Now what I have, when I multiply these, I'm just going to put them side by side, is AD over CD, or DC, doesn't matter the order, plus BC over CD. And now, since I have a common denominator, I can just combine these together. So the final fraction, because our goal is to get it to one fraction, is AD plus BC over CD. I just took each of the top parts, added those together. Similarly over here, I have AC minus BD. This is kind of the same idea as what we were just doing. The only difference, because we would multiply this by D over D, and this one by C over C. It's basically the exact same problem as what we just saw, it's just with the minus sign. So then our final answer would end up being AD minus BC over CD. I kind of skipped that step in between because the only difference is the minus sign. And then you're going to run into problems like this, where you have a variable on the bottom and a number in the other fraction. So again, just look for the pieces that you're missing. So this one is missing an x, so I'm going to multiply by x over x. This one's missing a 5, so I'm going to multiply by 5 over 5. This first fraction becomes 3x over 5x minus 2 times 5 is 10 over 5x, and then we're just going to combine them since we do have a common denominator now. So it's 3x minus 10 over 5x. All right. Now we're going to get into some tougher examples here. But again, our goal is to get a common denominator and then see if we can simplify anything afterwards. So in this case, we see a 2 and a 4 for the numbers. We can change a 2 into a 4. And the way that we do that is by multiplying by 2 over 2. The other thing we want to look at is the variables. Notice this one is x to the third, but this one's only a plain old x. So you can always take a smaller variable of x to the first and change that into x to the third by multiplying by x squared over x squared. So let's do the first fraction. 2 times 7 is 14 over, and then when I do the bottom, it becomes 4x to the third. So if I did this right, I should see another 4x to the third. So multiply the top, I get 5x squared over 4x times x squared does become 4x to the third. We know we did it right because we have the same denominator, or at least we're on the right track. Lastly, combine the top parts if you can. So it's 14 plus 5x squared over 4x cubed. Doesn't look like anything's going to reduce, so that's just our final answer. This one is even a little bit trickier. I'm going to actually space this out. I'm going to rewrite this so we can see what we're going to multiply by. So this one's 2 over 3x squared. I'm going to put plus 1/2. I'm going to leave myself some space because I'm going to multiply here. And plus 5 over 4x. So for the numbers, 3, 2, and 4, they don't have anything immediately that we can see. We know that 3 and 2 can both go into 6, but unfortunately 4 can't go into that, so we got to go even higher. I think the lowest common denominator in this case is going to be 12. So we need to figure out what numbers multiplied by each of those gets us to 12. Then we also need to get to an x squared. So this first fraction, we only need to multiply by 4 over 4. This one, to get 2 to become a 12, we're going to multiply by 6, but we also need an x squared. And the last one, space this out a little differently, we're going to multiply by 3x because we need to make that lone x into an x squared. Okay, so now 4 times 2 is 8 over 12x squared. This one, multiply the top, we get 6x squared, and then if done correctly, we should see another 12x squared, which we do. And then 3x times 5 is 15x, and then 3x times 4x is 12x squared. So we do see that common denominator, so we know that we were on the right track. Now, since we don't have any like terms on the top, we're just going to write this. Doesn't really matter the order, but you can write it in standard form since that's kind of the appropriate way to do it. So we would actually put the 6x squared first, the 15x, and then the 8. Again, it doesn't matter. You could go 8, 6x squared, 15x in any combination. It's still correct. All over 12x squared would be the final part there. Okay, now we're going to get into the ones where we have to factor. So notice on the left fraction we have x squared minus x minus 6. If we try to think of factors of 6 that have a difference of -1, that's going to be -3 and +2. So then our parentheses are x minus 3 and x plus 2. And notice we do see an x minus 3 on this side. The part that we're missing is the x plus 2. So that's what we're going to multiply when we're doing like the factoring types of problems. We're going to multiply by that whole factor of x plus 2. Okay. Now, we don't have to change anything on the first fraction. That one's good to go. I am going to leave it in factored form, though. I'm going to leave it as x minus 3, x plus 2. Now here, be careful because you have to distribute the 5. It's affecting both the x and the 2. So this becomes 5x plus 10 over, again, leave this in factored form. So it's x minus 3, x plus 2, because that way you can see that you have a common denominator. Now when we add these, look for your like terms. So the like terms are going to be 4 and 10. So then I'm going to get 5x plus 14. I know that those will add together. Over x minus 3, x plus 2. Now when you're subtracting, it's the same idea. You still want to get a common denominator, but we do have to be a little bit more cautious because of the subtraction part, and we'll see that in just a couple steps. This one, it looks like factors of 12 that add to make 7, which would be 3 and 4. So x plus 3, x plus 4. We do see the x plus 3 on this one, which means we need to multiply by the x plus 4 over here. Okay, so that first fraction stays the same. And then we want to, this is the part I was talking about, we have to be really careful. Since we're subtracting, you can go ahead and distribute the 5. So it'd be 5x plus 20 over x plus 3, x plus 4. But since we're subtracting this entire fraction, I want you to think of this as though it's in parentheses, and then we would distribute it, or you can think of it as adding the opposite. So this would be the same as adding negative 5x minus 20. So then we would get negative 5x, and if we do 4 minus 20, that would give us negative 16 over, that denominator doesn't change, x plus 3, x plus 4. So just be really careful when you're subtracting because you have to add the opposite, distribute that negative sign for all terms on the right side. Okay, just a couple examples left here. This one, we can factors of 9 that add to make 6 are 3 and 3. So it's going to be x plus 3, x plus 3. And then on this one, x squared minus 9 is x plus 3. That's a difference of squares, so it's x plus 3, x minus 3. Now notice, we do have an x plus 3 twice. We have one of them over here, but we still need an additional x plus 3 when we multiply. So we're going to get a really big denominator. And then on this side, on the left side, we're missing this x minus 3, so that's what I have to multiply by over here. Okay. Now, when you have two binomials like this, we have to do the FOIL method where we distribute all the terms, so we're going to get like a quadratic on the top. So that's what I'm going to do first. I would get x squared plus x minus 3x and then minus 3 over, again, just leave this in parenthesis forms. You can write it as x plus 3 squared if you want to save yourself a little bit of space since we have two of the same parentheses. And then we have an x minus 3 minus, and then we would distribute the 1 to each of these. And note, it's a negative, so we're still subtracting. So it's 1 plus 3, or 1x, over x plus 3 squared, x minus 3. And now we just want to combine our like terms. Remember to add the opposite here. So we're distributing that negative. This becomes negative x minus 3. So when we combine our like terms, we do get x squared. in this case, we can cross out these x's here since we have a plus x and a minus x. So then we'd be left with this minus 3x right here. And then we have a minus 3, don't let that one trick you too much, it's negative 6. Over, our denominator is x plus 3 squared, x minus 3. All right, last one. This one we see 5x minus 30. We can factor a 5 out of that, so it's x minus 6. And we do see an x minus 6 over on this one, so the only thing we're missing is a 5. So I'm just going to multiply by 5 over 5. So that first fraction stays the same. 5 times x minus 6 minus, now distribute that 5. It becomes 15x plus 20 over 5 parenthesis x minus 6. So now it's just combining like terms. Remember, we're subtracting, so that's affecting both parts. Add the opposite. So it becomes negative 13x minus 17 over 5x minus 6. There's lots of examples we can create for these. Some of them take a while, but just remember you're trying to get that common denominator and you want to factor right away to look for those pieces that you're missing.